Imagine a world where the idea of reaching the stars was just a dream. A world where the sky was not the limit, but an infinite canvas of curiosity. This was our world at the dawn of rocketry, a time when visionaries dared to look beyond the horizon and envisage a future among the stars. In the latter part of the 19th century, a Russian schoolteacher named Konstantin Tsiolkovsky began exploring the theoretical foundations of space travel. He was not a man of means or influence, but a man of ideas. Tsiolkovsky's theories paved the way for future space travel by proposing the use of rockets for space exploration. His equation, now known as the Tsiolkovsky rocket equation, is still used today to calculate the motion of rockets. Meanwhile, across the Atlantic, an American physicist named Robert H. Goddard was inspired by Tsiolkovsky's work and began his own experiments. He faced numerous challenges and skeptics, but his determination was unwavering. In the spring of 1926, Goddard successfully launched the world's first liquid-fueled rocket, a humble contraption that reached a height of 41 feet. This may seem modest by today's standards, but it was a monumental leap for mankind. The early days of rocketry were marked by trial and error, innovation, and sheer audacity. It was an era of backyard inventors and garage workshops, where visionaries like Tsiolkovsky and Goddard laid the groundwork for future generations. They faced countless challenges, from technical difficulties to societal skepticism. Yet they persevered, driven by their unwavering belief in the potential of space travel. These pioneers did not live to see the full realization of their dreams, but their legacy continues to inspire us. Their work ignited a spark that would grow into a flame, propelling us into the space age. It was these pioneers who laid the foundations for the space age that would follow. As the world moved into the 20th century, the competition to conquer space intensified. It became a grand stage where two superpowers, the United States and the Soviet Union, showcased their technological prowess and national pride. This was the space race, a thrilling chapter in human history that forever changed our relationship with the cosmos. In the late 1950s, the Soviet Union took an early lead. The launch of Sputnik 1 in 1957 marked a significant milestone. This shiny metal sphere, no bigger than a beach ball, was the first artificial satellite to orbit our planet. It beeped its way into history, sparking a sense of urgency in the United States. Not long after, in 1961, the Soviets achieved another remarkable feat. Yuri Gagarin, a young pilot and cosmonaut, became the first human to journey into outer space. His famous words, "Let's go," echoed around the world, inspiring a generation of dreamers and explorers. Yet, the United States was not to be outdone. In a bold response, President John F. Kennedy set a daring goal for the nation: to land a man on the moon before the decade was out. And so, in the summer of 1969, the world watched in awe as Neil Armstrong took his historic first step on the lunar surface, saying, "That's one small step for man, one giant leap for mankind." These events, these milestones, were not just about winning a race. They shaped the course of space exploration, pushing the boundaries of what we thought possible. They sparked scientific advancements and technological innovations that we still benefit from today. The space race not only propelled mankind into the cosmos, but it also ignited a passion for exploration that continues to this day. It's a testament to our enduring curiosity, our desire to reach further, to know more, to explore the unexplored. It's a story of human determination, resilience, and ingenuity. And it's a story that's still being written as we turn our gaze to the next frontier, Mars. Our fascination with the red planet is not new, but our efforts to explore it certainly are. Mars, our celestial neighbor, has been the subject of our curiosity for centuries. But it was only in the mid-20th century that we began to truly explore this mysterious planet. The first successful flyby was carried out by Mariner 4 in 1965, beaming back the first close-up images of Mars's surface. It was a pioneer, paving the way for future missions. Fast forward to the 21st century, and our exploration of Mars has evolved dramatically. We've sent multiple rovers, each more advanced than the last, to tread the alien terrain and seek answers. Spirit and Opportunity, the twin rovers, roamed the Martian surface for years, way beyond their expected lifetimes, sending back valuable data. Then came Curiosity, a car-sized rover equipped with an array of scientific instruments, landing in Gale Crater in 2012. Curiosity's findings have been monumental in transforming our understanding of Mars. It discovered evidence of ancient streams and lakes, suggesting that Mars was once a wet world, potentially capable of supporting life. And now, we have Perseverance, the most advanced rover yet, which landed in Jezero Crater in early 2021. It's on a mission to search for signs of ancient microbial life, collecting samples that could one day be returned to Earth. It's also testing new technologies that could pave the way for human exploration of Mars. Each of these missions has brought us closer to understanding Mars's past and its potential for harboring life. They've revealed a planet that's both alien and familiar, with landscapes reminiscent of Earth's deserts and polar ice caps, yet utterly unique in its own right. As we continue to explore Mars, we're not just learning about another planet. We're also learning about ourselves, about the origins of life, and about our place in the cosmos. Each mission to Mars brings us one step closer to answering the age-old question: are we alone in the universe? So, what have we found on Mars? The answer might surprise you. From the first grainy images sent by Mariner 4 in the mid-1960s to the high-definition panoramas beamed back by Perseverance rover, Mars has ceaselessly intrigued us. But it's not just the alien landscapes that capture our imagination. It's what they reveal about the history of Mars, and potentially, the history of life itself. Let's start with one of the most groundbreaking discoveries: water. In 2015, the Mars Reconnaissance Orbiter detected signs of liquid water flowing intermittently on the planet's surface. And if you're thinking, well, water is common on Earth, remember that water is the lifeblood of our planet. It's essential for life as we know it. Then, in 2018, the European Space Agency's Mars Express mission detected what seemed to be a subglacial lake. This discovery suggests that Mars, like Earth, might have a network of such lakes deep beneath its surface. If that's true, it could mean that Mars, a seemingly barren and inhospitable world, might actually have the conditions necessary for life to exist. Beyond water, Mars has also given us glimpses into its geological past. The rovers and satellites we've sent have found evidence of ancient volcanoes, riverbeds, and even glaciers. These findings suggest that Mars was once a warm and wet planet, much like Earth. Perhaps one of the most exciting discoveries is the detection of methane in the Martian atmosphere. Here on Earth, methane is primarily produced by biological processes, which has led some to speculate that the methane on Mars could be a sign of microbial life. These discoveries not only deepen our understanding of Mars, but also fuel our curiosity and drive to explore. Each new piece of information brings us one step closer to answering the ultimate question: are we alone in the universe? And with every rover, every satellite, every mission, we continue our quest for knowledge, boldly pushing the boundaries of what we know and understand. As we stand on the brink of a new era in space exploration, what does the future hold for Mars? Imagine a world where Mars is not just a distant red speck in the night sky, but a second home for humanity. A world where our footprints are not confined to Earth, but extend across the cosmos. This is not just the stuff of science fiction, but a tangible future that we are tirelessly working towards. The coming years promise a flurry of activity on Mars. We have missions planned that will delve deeper into the Martian environment to seek answers to our most pressing questions. We aim to understand the planet's geological history, its potential to support life, and its atmospheric conditions. Yet, the journey to Mars is not without its challenges. The hostile environment, the vast distance from Earth, and the technological hurdles make Mars a daunting destination. But these obstacles are not insurmountable. They are stepping stones, pushing us to innovate, to adapt, and to overcome. And then, there's the grand vision of human colonization. Establishing a self-sustaining colony on Mars is an ambitious goal, one that is fraught with peril, but also teeming with opportunity. It's a chance to start anew, to build a society that is a testament to human ingenuity and resilience. Mars holds the potential for scientific discovery and technological advancement. But more than that, it represents a beacon of hope, a symbol of our innate desire to explore, to learn, and to grow. The road to Mars will be long and arduous, but the rewards will be profound. We will uncover secrets about our universe, about our own planet, and perhaps about the very nature of life itself. Mars beckons us, inviting us to explore its barren plains, its towering mountains, and its hidden depths. It whispers of mysteries yet to be unraveled, of stories yet to be told. As we continue to push the boundaries of our knowledge and capabilities, who knows what secrets Mars has yet to reveal? So, let us embark on this grand journey, with Mars as our guide and the stars as our map. For in the pursuit of the unknown, we often discover ourselves.